Greetings! My name is Chastity, Selma, Jhingree, and today's topic is combination of finite sets of numbers. Combining finite sets of numbers. The type of numbers that we'll be focusing on are the natural numbers. Natural numbers are 1, 2, 3, so on, that goes off to positive infinity, that is never ending, it has no limit, and is not bounded. We have a well-defined collection of numbers, which is also known as a set of numbers. These set of numbers are being written in roster notation, where we begin with braces and end braces and separate each natural number with a comma that goes off to positive infinity, that is never ending, it has no limit, and is not bounded. These type of sets is considered to be an infinite set. The type of set that I'll be focusing on are the finite set that has a beginning and an end. It is not never ending, it has a limit and is bounded. For example, S is 1, 2, 3. It begins with 1 and ends with 3. These are the type of sets that we'll be focusing on when combining finite sets of numbers. To combine finite sets of numbers, we may consider the union, where we observe all the elements which are numbers in each of the sets. We may also consider the intersection, where we observe what each of the sets have in common. To define union and intersection by verbal notation or set notation. Verbal notation we use with words. Set notation we begin with braces and end braces an element in a set, colon represents such that so an element in a set such that properties of the element is in a set. So for verbal notation we would have, given two sets A and B, X is an element in a set. If A union B, then X is in A or X is in B are both A and B. If A intersects B, then X is in A and X is in B. And for set notation we would have A union B is X such that X is in A or X is in B are both A and B. We may also have A intersects B is X such that X is in A and X is in B. We may visualize the sets of A and B as a Venn diagram, where the elements of the set of A will be in one circle, and the elements of the set of B will be in another circle. What they have in common will be in the intersection of the two circles, which will be in here. What they do not have in common will be outside of the intersection. So for the elements of A that has nothing in common with B will be in here. And for the elements of B that has nothing in common with A will be in here. When we consider all the elements of A and B, it's considered to be the union. When we consider what they have in common would be the intersection. So for example, we're given two sets A and B. Let A equals 3, 6, 9, 12, and B equals 9, 12, 15, and 18. Find the union and intersection of A and B. We may plot the information of the elements of A and B as on a Venn diagram. It's best to plot the information what they have in common. So what they have in common is the 9 and 12, which is the intersection. And what they do not have in common will be outside of the intersection. So for the elements of A that has nothing in common with B will be 3 and 6. And the elements of B that has nothing in common with A will be 15 and 18. So given two sets, A and B, X is an element in a set. So for the union, we would have A union B is X such that X is in A or X is in B are both A and B, which is 3, 6, 9, 12, 15, and 18. And for the intersection, we would have A intersects B is X such that X is in A and X is in B, which is 9 and 12. Thank you for listening.